Ok, bonjour à toutes et tous. Alors cette session va être en anglais, donc welcome everyone. This session will be in English. Today we're very glad to have Nicolás García. He's a loyal member of the Nantes iOS community, and today he's going to talk about concurrency for iOS. Nicolás, the floor is yours.
Thank you, Rohan. Hello, everyone. This is Mutex Atomics and Beyond. Sounds a bit weird. In fact, my original idea was demystifying low-level concurrency and compile time safety in Swift 6, but it was a bit too long. So I decided that maybe this one was a bit catchier, but not necessarily easier to understand, but here we are. The context is, months ago I was working for, well, say, for a client. They asked me to build an algorithm on Swift. And the idea was to synchronize a number of files from between local devices and a remote server. So, I mean, that's not necessarily an extremely complicated feature to build, but because of Swift 6, I wanted to know, okay, what are my options here? I have already an idea of what I could do, maybe using dispatches, maybe using legacy concurrency. Let's take a look. This is also related because my client, they also do iOS development internally. So my propositions had to follow a certain criteria. So whatever I propose had to be simpler to understand. I had to be as performant as possible. Because of success, I wanted to get this promise compiled in safety. And of course, the iOS minimum version was a thing because they were targeting a very old iOS version. And if needed, it could be an argument to negotiate that aspect. Who am I? For those who don't know me, I'm an iOS and macOS developer on the side. I have been doing this since 2013. I have worked for a number of companies and from different domains. I think that since last year, I think that those are the two more well-known projects with BlaBlaCar and Electra. And also, in the past, I was a musician, in case you want to discuss about something else and not related to concurrency over a coffee. So, my train of thought when I was analyzing this is, okay, let's start by something very simple. I just need to define a simple application state. I'm going to start with a Boolean variable, a very beautiful Boolean variable. The thing is, you know that you cannot directly do that in Swift 6 because it's going to be considered as a global variable. There's no protection on what its access is. You could access that for many contexts or async context. So you take it a step forward. You put that. You enclose that in a type. Okay, great. You no longer have the compiler error, but it still isn't thread safe. Then another step further, you you define a serial dispatch queue. Great. Normally, you have a level of protection that's normally safe, at the cost of having a serial dispatch queue, which there's a little overhead on doing so. But again, there's no compile time safety because, in fact, nothing stops me from modifying the variable somewhere else outside the queue. And I have seen that in some projects. The thing is that we live in a world of concurrency, Swift 6. I wanted to know, okay, what do we have today? And for example, if this type that you have here, if you wanted to pass it along between different async contexts in the scope of Swift concurrency, of course, you will need your type to be sendable. As you are the one that is providing the implementation, you need probably to use the uncheck sendable annotation. But there, in fact, while the Swift 6 compiler is happy, in fact, you are the one backing up compile time safety. So it means that the code is as safe as your talent, I would say. So, yay, Swift concurrency at the rescue. What do we have that could do something kind of similar? You have actors. You have the same. You get serialization for free. That's great. I mean, it looks cleaner. You no longer have some sort of like a dispatch queue, some sort of locking mechanism in between. It's kind of very nice to read. You get serialization for free, and by definition, it's sendable, so you have to do nothing else. that's cool, that's great. But of course, there's a trade-off that if you do so, you're going to expose a synchronous API, so you are kind of forced to, with it for the caller, to provide an async context, and that could be, depending on where in your architecture layer you're placing this implementation, could be an issue or not. For example, let's say that, without going much into details on architecture, but let's say that you have your view layer that communicates with this implementation. Let's say that, okay, you could use the Swift UI view task modifier. So you get the async context for free plus cancellation. That is tied to the view lifecycle. So cool, great. It's easier. It's kind of easy to interact with an actor. But for example, say if you are dealing with other kinds of UI events, as just tapping on a button, you get callbacks that doesn't necessarily provide an async context. So it's up to you to define a task. And even if your task would normally inherit the main actor, there's a lot of boilerplate. So it's a bit, I mean, it's nicer on the implementation side, but on the caller side, it gets easy, a bit ugly. So there you have. My understanding was up to that point. Okay, this is one thing I can do. This is the other, but I wasn't entirely happy. So I started to take a look at other options. What else do what? And then I said, okay, I remember back in school, and also in a previous project, I have to work with video streams and like manipulating frames, and kind of I had to guarantee that there was a nice level or there was a decent number of FPS that were targeted in that project. So then I said, okay, what if I use logs? So you have NSLog, you have the NS prefix that tells you that this goes back a while from at least 20, 30 years. And in fact, you can ignore the rest of the code. In fact, if you use this kind of log, the thing is that, okay, you get the idea, you have to log and unlog, but if you are not very strict following best practices as possible, it's kind of easy to mess up the implementation and get into a deadlock. And of course, nothing stops you from doing so, so there's no compile safety at all. You are going to just to get a beautiful crash on runtime. Then I saw another log. You have the OS unfair log that come from the FTPC, but I was taking a look and I saw this. Apparently on Swift, there's some sort of wrapper type. You have the OS unfair log. They have the explanation there why you have to use this one and not the one that came directly from FTPC. And the thing I kind of got, it was I took note immediately. It was, okay, you have the iOS 16 requirement. So, okay, that's already something to keep in mind to negotiate with my client. Yeah. If you take a look at its usage, you see, okay, that's a bit nicer than the other one because you just get some sort of this scope where you can do stuff with the state that you're protecting, but in any case, nothing stops you from modifying that somewhere else. So no compile time safety. However, the log is documented to be the fastest log in iOS, and I thought that was very interesting. So I was taking a look at that article that's from Bruno Rocha. He's an engineer for Spotify, so I really like that blog. And I was very interested about taking a look at this. You have on the x-axis a number of operations, on the y-axis time spent. And you can see that, okay, in between the logs, okay, it's closer, depending on your use case, but the serial, if you pass by a serial dispatch queue, there's a huge difference if I was using the log. So then I say, interesting. But even if I used the dispatch queue, if I went with the actor option, am I forced to lose the compile time safety for performance? Well, am I forced to use the fastest log on iOS just because I want things to be fast? Sorry, this is not you. You have to go back and remember last year's WWDC. Maybe Liquid Glass takes all your attention now, but this happened not so long ago. And if you scroll over the end of the What's New in Swift video, the synchronization module was introduced like in 2 minutes. They said, okay, we have a new Mutex and a new Atomics implementation. That's great. They did a very simple demo. It's kind of easy to understand. But when I saw that, it was like actually Atomics, but they had announced an open source project about that some years ago. So I took a look. And yeah, it was announced during COVID times. I went into the repo and I found this very large pull request. I believe it was around 4,000 lines, where someone was trying to introduce a very interesting and complex implementation of Atomic, but by using non-copyable types. And it's kind of sad because the pull request never got to be merged into the project. Got stopped, and they just get this answer from someone from Apple, saying, in fact, this is the direction we want to go, but this is not the implementation that we want to have. And if you take a look at the dates, you have, okay, September 23. And some days ago, Swift 5.9 was released, and if you scroll down the changelog, there was this section talk about ownership for low-level memory management. There's some stuff, non-copyable types there, consuming, borrowing. Was like, okay, it's normally not the things I'm going to read first on the changelog of a new Swift version. So it looks a bit complex, but I was kind of interested to try to understand what's going on, what's the non-copyable thing. So then I said, okay, I'm going to give it a try. So, okay, you have 2 types, Mutex Atomics, you have the new keywords, and of course, there's a new requirement, iOS 18. So I went, taking a look at the documentation, you have, okay, Mutex, blah, 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 blah. The requirement, iOS 18. If you take a look at the type definition on its signature, you have, okay, Mutex is generic over a type, where its type has to be, and you have a weird symbol, a tilde, and it says copyable. I didn't get what was that, so later I realized that, in fact, if you put that tilde, it means that you're going to strip out the capabilities related to that protocol. It's kind of weird. It's called a negative constraint. So, for example, if you have a struct, you normally get copyable for free. Normally, that comes from Foundation. So this is a very interesting way, and of course, it's maybe you saw it. There's already people complaining that on Swift we have so many keywords. But one more, what's the harm, right? So, non-copyable types. The promise is, in fact, that you're going to manage, or you are capable to manage one instance, could be of a value type, that you could think that looks as some sort of singleton, but that's not the case because you're not able to access it from different places at the same time. You get as a single instance that you could eventually temporarily share with another context. Then you get your instance back, or you could transfer the ownership of this instance to somebody else, and then your current instance gets invalidated. That, by definition, resolves the data races by design, and that's quite nice. But I thought, okay, right, maybe this could look nice on the implementation I was doing, but this is kind of weird. Then I realized also by taking a look at the Swift evolution proposal, I left the link, sorry, there if you want to take a look, it's the 433. That is not something new at all. On Swift, yes, but in fact it comes from C++. It's called move-only semantics. Maybe if you do embedded, you work in embedded projects, maybe that's more familiar to you. For me, it wasn't at all. So you have these 2 keywords, borrowing, consuming. As I was saying, you either have the possibility to temporarily transfer the ownership of your single instance to somebody else, and then you get the instance back. Or you could just completely transfer the ownership of your instance, and then whatever reference you have to your instance, it gets invalidated. So it's impossible to modify a single thing from different places. That's kind of cool. So let's take a look at a very simple code example. Here, for example, is it readable enough? Yay. So you have this very simple implementation of a value type. We are conforming to the non-copyable negative constraint. Use a random property there. And follow me here. You have a random function. Here I'm instantiated an instance of my value type. I'm temporarily passing my instance to another context. So this is called. I'm using the borrow keyword. And here I can simply do an operation. For example, here I'm just reading a property and printing it. Great. The function returns. And I'm still allowed to do stuff here with my value type. But if we do this, it changes a bit of stuff. It says that, okay, here I'm transferring the ownership of my instance because I'm applying the consuming keyword. Here, in fact, I'm doing exactly the same operation, but as we have the keyword consuming, whatever instance I had on my previous context, this is the caller side, in fact, I get invalidated, so I cannot do anything with my instance because it was invalidated. I cannot even, well, I cannot do anything with it. So I could show you, I think, this one. I was trying something here. For example, here I'm using the synchronization mutex type. The same thing I'm applying the same value type, which could be modified inside the lock. And the thing is that if you take a look at the constructor, oh, I think something changed, but it said that is consuming. Yeah, there you have it. You have the consuming type. So, in fact, so that forces me kind of like to instantiate wherever I want to protect with the mutex, whatever resource I have there. And by definition, it cannot be modified anywhere else. But I tried doing that. I said, what if I do this? And then it complains, it says, okay, you're kind of borrowing the value, but because you could modify this, but somewhere else. So that was kind of cool. Then I said, okay, great, but I still have the iOS 18 problem, but that was something to negotiate with my client. Then taking a look at digging up more information about this, I found this from that blog. But you have a very simple benchmark about if you go over a number of operations. This, of course, depends a lot of your use case. You have that the lock is the OS unfurlock, the fastest one. Okay, you have a number, it's the lowest one. Actor takes double because you get more overhead. And Mutex falls somewhere in between. And then I said, okay, what's the reason? And in fact, if I was taking a look at the Swift evolution proposal, and I saw that, in fact, that the Mutex implementation relies on the OS unfurlock. So then I said, okay, great. In fact, behind the scenes, that's using the fastest lock available, plus you get compile time safety. So the little overhead that you get is compile time safety. So I did a beautiful table to kind of to get an idea of what were my options. Sadly, I couldn't directly jump into iOS 18 as the minimum required version, so I have to fall somewhere in between using the lock and using actors. But it's very nice that this exists. I have no idea if you tried also during the last year. So wrapping up, you get performance versus safety trade-offs. If you want to go as fast as possible, because again, you are dealing with something that requires the best performance as possible. Maybe you're dealing with video, maybe your application deals with some background processing, maybe you are training a local model. But Depends on the use case. Maybe you don't want to get this extra overhead and you're okay with not having the compile time safety because you cannot know what you're doing. Then great. Otherwise, you get this option. If you can jump up to iOS 18, you can use the Mutex. That's great if you want. It's the same thing for the Atomic new implementation. And for the rest, of course, it's okay to keep using actors, for example, for the rest of the code. For example, if you have like a layered application, like a typical MVVM with repositories, etc., you can keep using actors. It's okay. It's kind of like the extra overhead that you get. It's okay because it's not the number of operations are not the same. Maybe you're just doing like a regular server request to an API REST, to a REST API server or using GraphQL. It doesn't matter if number of operations are still smaller in numbers. And here there are a number of interesting articles, of course, in my opinion. And otherwise, that's all. Thank you.
All right, thank you very much, Nicolás. We've got plenty of time for questions. Do you have any?
Thank you very much. In what kind of context did you use it for your client, this kind of unlock?
What I can say, there is an NDA, but whatever. Again, it was the context is an application where you can store files on a server, a private server. So you can imagine something similar to Dropbox or Google Drive. And you need to deal with a number of operations to keep your files synchronized. Of course, you could be logged in from an iPhone, of course an Android phone, from your Mac, from several places. You are also able to modify anytime. You could delete a file on your phone, from the web, etc. A lot of things are going on there. But for example, the use case was mostly I need to have a way to get like some sort of like a simple indexing of the files I'm managing locally. And I need a simple way, that was kind of like my criteria, where I can keep this index as updated as fast as possible. I'm pretty sure that if I used to use the dispatch queue, that would have done the job. Yeah, it would work. But we are on a CIF6 world, so I wanted to know what's around. Yeah, of course, then discussing with members of the community, well, Frank Lefebvre. Normally, you are more intended to use this kind of like a more performant looks. If you do embedded Swift, it would be, but not necessarily. Depends on the project. I think that for more common applications, as application does a number of requests to a REST API server, you get some information back. You're going to parse this information a certain way. You display it over lists, etc. Like the more common type of application. Maybe you don't need it. Just actors, works great. But it was a more specific use case I wanted to know. Yeah. And also, well, just to do the promotion, but years ago I worked for this company, it's called Speech, and they dealt with video. You were able to, for example, to record, to use the screen recording, and they kind of like the challenge was, okay, as I'm recording a video, I want to cut it in chunks and upload it to a server. It was the same as you are on, exactly as you are on an application is in a background state, you have memory constraints, so you want to keep your kind of like the overhead of operations as small as possible, because already the video chunks takes a lot of space in memory. So that was another use case that I kind of like recently saw.
All right, thank you very much.
De rien. Merci les gars.